The last bit of new information in the meteorology unit that we are going to cover this year has to deal with the tools of the meteorologist. So I always say in everyday science class that I try to make you guys amateur scientists and do the jobs of actual scientists. So in this case, since we're the meteorology unit, I try to get you introduced to the tools of the meteorologist. So this little thing is kind of this note package here is pretty much just an overview of the different types of tools can be used. And a lot of them you've seen before and maybe used before, and then some others that I will make sure I give you the terminology too. But from there, we're going to then talk about station models and how weather is recorded, so that it's not just a bunch of writing on a map. It is pretty much pictures and drawings that resemble the type of weather of a certain area at a certain time. So let's go over what we've talked about so far. We've talked about a barometer to a point. We talked about air pressure and what air pressure was, the difference between high pressure and low pressure. The barometer is the tool that measures air pressure. So the picture on the right is a typical barometer. It's basically a needle device that the needle will move to the right and to the left. To the right it means higher pressure, to the left means lower pressure. Now this barometer is even more special because it gives indication to the type of weather that usually is associated with this type of air pressure. So high pressure being, more air molecules than water vapor molecules, so therefore nicer weather. So when the needle is pointing to the right, you get fair or even very dry if there's no water molecules or very few air molecules in the air. As the pressure changes and maybe drops, that's where it's change in the weather is going to take place. And if it moves to the left, you can get usually precipitation, usually rain or snow, and then sometimes when it drops even lower, a low pressure system passes through an area. That really is a good indicating of heavier storms, whether they be snowstorms in the winter or they be severe thunderstorms in the summer and spring and fall. So a barometer can really give a good prediction to whether that is present and whether that is coming based on reading that needle. The sling psychrometer we did in class, and I showed a little bit of a demonstration of. I sent a video along with this to demonstrate how a sling psychrometer works. Sling psychrometer is what measures air temperature, air humidity, not temperature. How much relative humidity is in the air, how much amount of water is in the air. So it's two thermometers. One's got what's called the wet bulb, the one with a cloth on it, the other with a dry bulb. You put a couple drops of water on the wet bulb one, and then first you record the temperatures before you spin it, and then you spin it. The spinning causes the air to dry the water off of that piece of cloth, but the problem is when that happens, it drops the temperature of the thermometer that's underneath, the bulb of the thermometer that's underneath. So the thermometer, one thermometer with the cloth is actually going to read a lower temperature than the one on the right. The farther apart those two numbers are from each other usually indicates the lower the humidity is in the air, because a lot of evaporation is taking place very quickly to dry that cloth. If the cloth won't dry, or there's really no change in temperature between the two thermometers after you've spun it for, let's say, a minute or 2 minutes, then the air is a good indication that the air has got a large amount of humidity, that because the air won't, or the water won't evaporate off of that piece of cloth. Another tool that is here is the anemometer. The anemometer is a device that measures wind speed. So if you look at the picture on the right, it's pretty much a device with 4 cups on the end of it. The cups are concave in nature so that they will catch the air in any direction, and it'll cause the air movement will actually cause those cups to spin. What scientists or meteorologists will count is how many times that cup spins in a certain amount of time. From there, you can calculate the speed of the wind. So obviously, the faster it moves, the higher the speed of the wind. The lower it moves, the lower speed. But to get an exact number, there's actually a formula to plug those numbers in based on the circumference of the cup. So there's a video link I put to this page. So when you're looking at the notes separately, to look at that video, you need to click on the link that's below. Same information, similar information with the windsock or wind vane. The windsock wind vane will measure wind, but not the speed of the wind. You have no idea what the speed of the wind is looking at one of these devices. What you can tell from this device is direction. So the wind vane on the right which has got the rooster shape in there, usually got an arrow that's pointing to it, and usually gives you an indication where wind is coming from. And then the windsock on the left-hand picture, you see those at airports, golf courses would have windsocks, give you kind of an idea of the direction the wind is traveling. So each of these things will actually measure wind direction. Again, I have a video link that kind of sums up anemometers and windsocks and wind vanes to make sure you understand the difference between them. It's in these notes. Click on the link that is provided. The other two tools of a meteorologist, what I didn't think I had to really explain, was the thermometer on the left and the rain gauge on the right. Well, thermometer is just basic temperature, okay, finding out how much heat or absence of heat is in the air temperature, and that's what's recording on the left, Celsius and Fahrenheit, on that thermometer. A rain gauge is a device that you put outside, and it's almost like a big cylinder, a graduated cylinder that gives you labels of how much rainfall has occurred. So it collects the rainfall, and then you go out and look over a storm, and you can tell how many inches of rain fell or snow fell in a given period of time. So when they talk about, it's 3 to 5 inches of snow this week, or it rained an inch and a half, 2 inches, the rain gauge can be your indicator to the amount of rain that fell. Okay, so those are all the tools of the meteorologist. So now what I want to get into is the idea of what station models are. For a meteorologist to record their data of a certain location, and they can measure hundreds of different locations. When you have a big map to draw out, sometimes it's easier, instead of writing the words of the temperatures and all that different information for your one location, sometimes it's easier to use symbols that represent everything you want to say. Well, that's what a station model is. A station model is a symbol system that can give you a lot of information about a certain location in a small space. So what I have in the picture here, on the slide here, is I have a station model, an example of a station model, which is on the left. On the bottom, I have examples of the different types of symbols for the middle between the temperatures on the left to indicate what type of weather is taking place, whether it be snowing, raining, fog, thunderstorms. So that's what's on the bottom. Now, wind speed is measured in a certain way where you give a symbol for the wind speed, and I have listed there, the one thing I found online was the wind speed in knots, in miles per hour, which is the middle column, and then kilometers per hour. Obviously, we'll focus on miles per hour for right now. But if you wanted it in kilometers or knots, especially with sailors, we'll look at the one in knots for when they're sailing their vessels. That's what that list is, and they give you different symbols for each of those. So, knowing all this information, I can kind of give you an indication of how to read one of these station models. So let's take a look at the station model first, and then we'll test one out, see if we can't create one of our own. I'll start from left to right. So right here is temperature. Okay, the current air temperature is right there, and that's 73 degrees. Down here, which I didn't have you guys record in class, but we can do that from now on, is the idea of dew point. Now, the dew point temperature is a temperature that's it's usually analyzed compared to the current temperature, and depending on how close or how far they are from each other, usually indicates the amount of humidity in the air. So usually when these two numbers are together, it usually indicates that the humidity is actually pretty high. When these numbers, when this number and this number are really far apart from each other, then it kind of indicates that there's very little humidity in the air. So the closer they are together, the higher the humidity. The middle symbol here is types of precipitation. So down here, if it's rain, we draw a dot. This type of rain, 2 dots, indicates usually light rain. If you have a third dot, let's say we put a third dot up here, that usually means moderate rain. And then if you put a 4th dot here, sometimes it indicates heavy rain. Well, same idea with the snow. If you make them like these asterisks in that same spot, that would indicate snow in that location. Obviously, the temperature being 73, snow is not going to happen anytime soon in that picture. Now, also looking at this picture, we see wind speed, wind direction, and we also see sky cover. So to continue, and I may be repeating myself because I had to pause the video for something else, I'm in the middle of the section here talking about wind speed, wind direction, and even sky cover. So I'm looking at this symbol right in here. It's amazing with one symbol how I can tell 3 different things. The chart on the right actually indicates the symbol that's used when it comes to wind speed, and then the circle is going to indicate wind direction. So let me begin talking about the circle itself. In the circle, the reason why it's shadowed like it is, it usually gives an indication of cloud cover. This is a sky cover in the picture there. So if this circle was completely bare with no shading in it whatsoever, it means it's a sunny day, very low cloud cover. The half kind of gives you a mostly cloudy day or a partly cloudy day. Either indicate, you can be correct with either indication. If you were to see a symbol similar to this, so to fill in this even more, okay, that would be really a no-brainer to say that's a mostly cloudy day, or just cloud cover would be the circle completely filled in. So the circle, inside the circle indicates cloud cover. The stick that's attached to the circle is actually indicating direction. So you have to pretend that this circle is like a big compass rose. Here's north, here's south, here's east, and here's west. Okay? Where the stick is hitting the circle is an indication of where the wind is coming from. So if in this picture, in this model here, you could pretty much make a case to say that the wind is coming from either the northwest or even the north-northwest, because halfway between N and W would be northwest, and it's not quite halfway, it's a little bit up the circle. So I would say north-northwest is where the wind is coming for right now. Now the symbol here, if I look at this symbol, I've got two lines at the end of the stick that are the same length. Now it's tough to see in the picture over here, but most likely I'm going to be looking at that one because it looks like those two are together. So which means my wind speed in miles, oops, as I cross it out, is 21 to 25 miles per hour. So when you get a recording of wind speed, how much it is, you got to find the symbol that matches, the actual number, and then that will indicate the wind speed. So in one picture, I can tell you the cloud cover, the wind speed, and wind direction that's listed there. Now, the other part of this, which I'm not going to get too much into, is pressure. So they have sea level pressure there. This is in millibars. The number you see in front of you is in millibars. I'm not going to be that specific with millibars. Usually with what you write off of weather.com is in inches. So I'm not going to ask you guys to actually record the pressure at all. If you want to, you can. And then the rising and falling, that's what this trend line is indicating. So it's either rising, it's falling, or it's steady. If it was steady, it would look like that. If it was rising, it would look more like that. But right now, it looks like it's falling, according to this picture. So that's kind of just a brief overview of how to read one of these station models. But in this small picture, I can give you an indication of a location and all the different weather data that you need to record. So with that being said, we're going to try one. Okay, so try to draw using the following information. I'll give you a chance to do it before I actually do it as well. Let me read the instructions here. So it's a mostly cloudy day. Temperature is 58 degrees with a dew point of 54. The wind is moving from the east-northeast at 13 miles per hour, and the precipitation for that day is moderate rain. So your task is going to be to draw a station model that matches this information. So it might be best to start with a circle. And you have to forgive my drawing here since I'm doing it online here using my mouse. Mostly cloudy usually means most of the circle is filled in. I'm not going to spend all the time filling it in here. Just so you get my idea. Okay, there's a mostly cloudy day. Good enough. Temperature is 58. Dew point is 54. Okay. Moderate rain, so I'm going to put 1 dot, 2 dots, 3 dots, pretty much indicate moderate rain. And the winds east-northeast 30 miles an hour. Now if it's at the west, you're going to have to move this stuff over. I've got a small space here that I want to draw this in, so I want to make sure I get it in there in the right spot. Winds east-northeast. Well, here's north, here's east. East-northeast means it is closer to the east than it is the north. So I'm just going to put a line like that. It's definitely a line because it's definitely have wind. If it was calm, then right next to that circle, I would put this symbol here, right here. Okay? But since it's not, Oh, I don't want to erase because now I'd have to do it again. So I'm not going to push the erase button just yet. 13. So I'm looking at 13 miles per hour. That is this one. So therefore is this symbol. That's easy enough. I can just basically at the end of the stick is that. So with the exception of the X that's out there, this is a station model, and then the N and the E. This is a station model that shows me all that information in one simple picture. Okay, so that's a good example of station models. In your weather workbook, I give you about 10 to draw and create, and you can use the sheets before, the pages before, to give you the idea of the symbols and where to put things. So we'll check over those and see how well everybody does in the coming days. But if you have questions, please do email me and I can help guide you, or even send me your work and I can check to see if you've got it right.